Hello everyone, welcome to an algebra video tutorial learning about exponent properties. We're going over another example about using all the different exponent properties we've learned: the product property, the quotient property, the power of a power property, zero exponents, negative exponents, and being able to apply all these properties to take a complicated algebraic expression and simplify it down nicely. So simplifying expressions using exponent properties. And it's simplified, all the exponents are simplified when we have no repeated variables. So what that means is, in this case, I have m on top and I have m on the bottom. I have n on top and n on the bottom. And my final simplified answer, I really only have one m variable and one n variable. And that's going to be a simpler expression. I also need to have no negative exponents. Exponents are confusing enough. Let's get rid of all the negative ones, right? No negative exponents. Make things simple, clean, all positive numbers. And then make sure things, if we have fractions or if we're dealing with stuff, make sure everything is just simplified into lowest terms. Here I've got a 4/10. I can already tell I got some work to do to put that into lowest terms. Okay, let's start simplifying this one out. So we've got a fraction. I've got 4 times m to the negative ninth power and n squared divided by 10 times m to the negative 6 times n to the fifth, and the whole thing is taken to the negative second power. Now, on a problem like this, it may be tempting to want to take the negative 2 power and start applying it to everything. And you could. That'd be applying an exponent to a fraction. You do it to the numerator and the denominator. But what I would do is I'm going to simplify things inside the parentheses first, because I can use some quotient properties stuff here. I can simplify the 4/10. And once I've simplified it, it'll make it a lot easier to apply the negative 2 exponent on the outside. All right, so let's start working on the inside. 4/10, I'm just going to divide out the 2, that's a common factor, and reduce it down into 2/5. That's pretty easy. I can do that to start off with. Now let's just work with each variable one at a time. Let's go with the m's. I have m to the negative ninth over m to the negative sixth. The quotient property says when you're dividing the same base, m divided by m, I can subtract the exponent. So that turns into m to the negative 9 minus the negative 6 power. And I can do the same thing with the n's. Quotient property says I can subtract them. So that becomes n to the 2 minus 5. All of this is to the negative 2 power. So I'm going through step by step really slow. You may wonder, why didn't I finish it off? Why am I stopping? That feels like I made it more complicated. But I'm trying to show bits and pieces, step by step, how I'm working through and getting there. And what I did was I just used the quotient property. I wrote everything division, I wrote it as subtracting the exponents. Okay, let's simplify all those now. So we still have 2/5. But now let's do the subtraction. Negative 9 minus negative 6 turns into negative 9 plus 6. So I end up with m to the negative third. And for n, it so happens 2 minus 5 is also n to the negative third. And it's all to the negative 2 power. Well, it's simplified on the inside. Now let's go ahead and apply the negative 2 exponent to everything. So negative 2 to the fraction is going to turn into 2 to the negative 2 power divided by 5 to the negative 2 power. Negative 2 applied to the m, I'm going to use the power of a power property to rewrite that as m to the negative 3 times 2. And same thing here, that negative 2 gets applied to the n variable using the power of a power. We multiply the exponent, so it's negative 3 times negative 2. And I just realized I didn't put the negative on the other one. This should be negative 3 times negative 2. So again, with the negatives, they get complicated. It's really easy to lose one. All right, so we've taken the power of a power property, and now I can go ahead and multiply those exponents. So let's go hit the fraction here at first. 2 to the negative 2 power becomes 2 to the positive 2 power, but only as division. Instead of multiplying on top, it becomes 2 to the positive 2 on the bottom as a division problem. 5 to the negative 2 power, instead of division, goes above. It becomes multiplication by 5 to the positive 2 power. So we're dealing with our negative exponents. We're starting to do some things there. And again, that was a negative exponent property. And I forgot to write here, we should have shown that we did power of a power. So we've got quotient property, power of a power property. Now we're using negative exponents. Let's deal with the m. So m to the negative 3 times negative 2 becomes m to the positive 6th power. I like positive exponents. And then n becomes negative 3 times negative 2 becomes n to the positive 6th power as well. So I'm using my power of a power property, multiply my exponents together, and I'm getting closer. I'm right there. So my final step is I'm going to rewrite it all together. 5 squared becomes 25 times m to the 6. It's a positive exponent, so it's on the top of the fraction, times n to the 6th. And it's all divided by 2 squared, which is 4. There we go. We've just simplified it out pretty well. I'm feeling pretty good about that. There's no repeated variables. There's only one m and one n. There's no more negative exponents. We've got things into the lowest terms. And it's a much friendlier, much nicer expression to work with. All right, hopefully that was a good, helpful example for you. We used the quotient property. We used the power of a power property. We had to do some stuff with negative exponents. Keep in mind now, this was just one way to approach this problem. There are actually a couple, 2 or 3 different ways I could have gone about working this thing, showing my work, thinking about this problem. So go ahead and attempt it on your own. If you think you know a different way, go ahead and attempt it. You should still end up with the same answer, but it'd be kind of a nice way to challenge yourself. But there you go. There's a great example of simplifying an expression using exponent properties.